Assalamualaikum and hi. In this video, we will learn about the differentiation of vector function, orthogonal vector, velocity, and acceleration from position vector.
Now I will explain about the velocity of a vector-valued function. Velocity is defined as the derivative of the position vector, which we write as vt is equals to drt over dt. This vector tells us not only how fast an object is moving, but also in what direction it's going, which makes it so different from just speed. For example, if we were given the position vector, rt is equals to d squared sin t e to the power of t. If we differentiate it, we can get the velocity, which is the answer is 2t cos t and exponent to the power of t. This means at any time t, we know exactly how the object is moving in space. As on a graph, the position vector traces the path of the object like a curve in space. The velocity vector is shown as an arrow that is tangent to the curve at specific point. This means that arrow points in the direction the object is moving, and its length represents the speed. Velocity vectors are always tangent to the path of motion, which makes it so useful in real life, such as tracking a car, or needed in drone flight path, or helping engineers model and control motion. That's all from me.
Acceleration. Definition for acceleration is the second derivative of a vector-valued position function. It tells how fast the velocity is changing within time. So step by step, we got the ft equal to fti plus gtj plus htk. We need to differentiate it two times, which is the first time is velocity and the second time is acceleration. So for example, ft equal to t squared I sin tj and e power by t k. So we got the acceleration is at equal to 2 minus sin t and e power by t. Orthogonal. Definition for orthogonal is two vectors are orthogonal in bracket perpendicular if their dot product is 0. So based on formula we got here, we need to multiply a with b. So when the answer is 0, it is orthogonal. For example, we got here is a equal to 2t, t power by 3 and t squared. For b, we got that t power by 3 minus 3t and t squared. So we need to use dot product for this to got orthogonal. So we got that 2t multiply by t power by 3 plus t power by 3 multiply by minus 3t plus t squared multiply by t squared. We got that the answer is 2t power by 4 minus 3t power by 4 and plus t power by 4. After we done the calculation, we got that the answer is 0, which is orthogonal.
For the easy example, we just take the equation of the position vector and then differentiate it to get a velocity. So from 2ti plus 3tj, we differentiate it and then we can get 2i and 3j. Then to calculate the acceleration, we just differentiate the result of the differentiation of the velocity to get 0i and 0j. So the final answer will be velocity 2i plus 3j and acceleration will be equal to 0. For the medium example, we just have to find the velocity, acceleration, and whether the equation is orthogonal at t equals to pi over 2. So, as usual, from the position vector, 3 square I plus sine tj, we just differentiate it and then we get the velocity which is 2ti plus cos tj. And then we differentiate it again to get the acceleration which is 2i minus sine tj. And then we just substitute the value given at t equals to pi over 2 into both equations, and then we will get velocity equals to pi I plus 0j, and the acceleration will be 2i minus 1j. In order to find out whether they are orthogonal at t equals to pi over 2, we have to find the dot product by multiplying both equations. After multiplying velocity and acceleration, we got 2 pi, which is not equal to 0. Hence, it is not an orthogonal at t equals to pi over 2 because the dot product isn't equal to 0.
So I'm gonna explain about the hard example, which the question is RT equal to T sin T, T cos T, and ln T plus 1, and T more than negative 1. So for question A, find the velocity vector and acceleration vector. So to find velocity and acceleration, we need to differentiate each component of RT. For velocity, which is first differentiation of RT, we need to separate the function of RT, which is to xt, yt, and zt. For value of xt, which is t sin t, we need to differentiate this function and we will get sin t plus t cos t. For the second function, which is t cos t, we need to differentiate and we will get cos t minus t sin t. And for the third function, which is zt, which is ln t plus 1, we need to differentiate this and we will get 1 over t plus 1. To find acceleration, we need to differentiate velocity. So it is the same meaning as the second differentiation of RT. So for the x differentiation of x, we need to differentiate the function that we got in the velocity, which is sin t plus t cos t. We differentiate, we will get cos t minus sin t plus cos t minus t sin t, and we will get 2 cos t minus t sin t. And for yt, we will get from cos t minus t sin t, we will get negative sin t minus t cos t. We will get negative 2 sin t minus t cos t. For z, which is 1 over t plus 1, we differentiate, we will get minus 1 over t plus 1 squared. So to write the answer, we need, for velocity, we need to use dot product and write the function x, y, z back. And don't forget to put comma in each of the function. For acceleration, we just simply put back the function, which is 2 cos t minus t sin t, comma negative 2 sin t minus t cos t, comma negative 1 over t plus 1 squared. For question B, at time t equal to pi, determine whether the velocity and acceleration vector are orthogonal. So are V and A orthogonal? So we need to compute both vector at t equal to pi, which means we need to change all value of t in the function into pi. So we know sin pi equal to 0 and cos pi equal to -1. So we need to insert the formula we know into the equation. So for velocity, we will get minus pi, minus 1 and 1 over pi plus 1. For acceleration, we will get minus 2 pi and minus 1 over pi plus 1 square. After that, we need to compute the dot product, which is v times v function of pi times a into the function of pi. So we need to multiply the x to x, y to y, and z into z. So we will get minus pi times minus 2 plus minus 1 times pi plus 1 over pi plus 1 times minus 1 over pi plus 1 square. So the end value will get pi minus 1 over pi plus 1 square, a cube. We will get pi minus 1 over pi plus 1 cube. So the dot product we get is not 0, which means the vector are not orthogonal to each other, because we know orthogonal concept must be equal to 0.
Now let's move on to question C. You will be asked to find the speed of the particle at time t equal to pi. As you may remember, speed is just the magnitude of the velocity vector. We already found the velocity vector to be vt equal to sin t plus t cos t negative t sin t, and 1 over t plus 1. So t equal to pi, we substitute the value. Sin pi equal to 0, cos pi equal to -1. And then you will get negative pi, -1, and 1 over pi plus 1. Now we calculate the magnitude of this vector. V pi equal to negative pi square plus -1 square plus 1 over pi plus 1 square. This simplifies to V pi equal to pi square plus 1 over pi plus 1 square. So the particle speed at t equal to pi is exactly this expression. Now let's move on to question B. You will be asked to calculate the arc length of the particle path from t equal to 0 to t equal to pi. In simple terms, this means finding out how far the particle travels along its 3D path during that time. Since we are given a vector function, we will use the arc length formula for vector value motion as equal to the integral from t equals 0 to t equals pi of the magnitude of the velocity vector v of t dt. That means we need to find the magnitude of the velocity vector and then integrate it from 0 to pi. From part A, we already have the velocity vector vt equal to sin t plus t cos t negative t sin t, and 1 over t plus 1. Now to get the magnitude, we apply the vector magnitude formula. Vt equal to sin t plus t cos t all square plus cos t negative t sin t all square plus 1 over t plus 1 all square. After expanding and simplifying those square, we will get Vt equal to z 1 plus t square plus 1 over t plus 1 all square. So S equal to integral pi 0 z 1 plus t square plus 1 over t plus 1 all square dt. After evaluating the integral, we find the arc length is approximately 6.14 units.